Hello everyone. So we are from Group 21 and we'll be presenting on the topic AI tools for generating UML diagrams. So to begin with, I'll be giving a brief overview on what UML diagrams are. So UML diagrams or Unified Modeling Language is a standardized modeling language that helps software developers, analysts effectively. It provides a visual representation of a system structure behavior, making it easier to understand, design, and communicate complex ideas. So moving on, there are two main categories of UML diagrams, structural diagrams and behavioral diagrams. Structural diagrams focus on static aspects of a system. These include components such as classes, objects, and their relationships. The most common structural diagram is the class diagram, which represents the system's architecture by showing classes, their attributes, methods, and how they relate to one another. Other structural diagrams, such as component diagram and deployment diagrams, are used for more specific purposes like visualizing physical deployment of a system. So the next one is behavioral diagram. Behavioral diagrams, on the other hand, capture the dynamic aspects of a system, such as processes, workflows, interactions over time. For example, use case diagrams show how users interact with the system to achieve specific goals, while sequence diagrams illustrate the flow of message between objects over time. Similarly, activity diagrams are used to model workflows or businesses over processes. So each diagram serves a specific purpose, and together they provide a comprehensive understanding of the system from multiple perspectives. For instance, while class diagrams give a high-level view of the system's architecture, a sequence diagram divides into the nitty-gritty details of how objects interact with specific scenarios. So next, Amasha will be speaking on how AI tools have impacted UML diagrams.
Thank you, Venuki. I will be talking about the AI tools for generating UML diagrams. UML diagrams are essential in software development for visualizing and designing systems, and AI tools make creating these diagrams faster and easier. Let me highlight 4 popular tools and their features. First, we have Lucidchart, a cloud-based tool by Lucid Software. It uses AI to provide auto suggestions for UML classes and relationships. For example, typing class customer can instantly generate a diagram. Next, PlantUML, an open source tool that converts simple text into UML diagrams. It's highly favored by the developers for its text to diagram approach and support for class sequence and use case diagrams. StarUML, a desktop tool by MKLab, uses AI to suggest components, and it's ideal for creating detailed diagrams for complex systems. Finally, Visual Paradigm is a versatile tool with AI capabilities for creating diagrams directly from requirements, reverse engineering code, and supporting collaboration through crowd integration. Moving on to the comparison of tools. Now let's compare these tools based on their AI capabilities, ease of use, collaboration, cost, and ideal use cases. In terms of AI capabilities, Lucidchart and Visual Paradigm stand out with the advanced automations and suggestions. PlantUML focuses on text-to-diagram conversion, while StarUML uses plugins for AI-driven features. For ease of use, Lucidchart and Visual Paradigm are very beginner-friendly. PlantUML requires learning syntax, and StarUML works well if you're familiar with UML. When it comes to collaboration, Lucidchart and Visual Paradigm are excellent for cloud-based teamwork, while PlantUML is more limited. StarUML supports collaboration locally but not on the cloud. On cost, PlantUML is free and open source. The others are paid tools with free trials available. As for ideal use cases, Lucidchart and Visual Paradigm are best for team handling large projects. PlantUML works well for small teams and developers, and StarUML is suited for creating detailed diagrams for complex systems. In conclusion, each tool has its unique advantages. Choosing the right one depends on your project needs, team size, and budget. Over to you, Mitma.
This slide highlights how natural language processing helps in creating UML diagrams. Text-to-diagram translation. turns written text into UML diagrams automatically. Entity recognition identify and classify key elements like entities, attributes, and relationships within the text. Syntax and semantics analysis understands the structure and meaning of the text. Context-aware modeling uses the context to create more accurate UML diagrams. Now, let us discuss about some key challenges that can be identified in current UML tools. Learning curve. These tools can be difficult to master, which makes it harder for new users to get started quickly. Limited AI integration. They don't make full use of AI features, which could simply and speed up many tasks. Customization limitations. The tools offer limited options for personalization, making it hard to tailor them to specific needs. Collaboration issues. Working together as a team can be challenging due to limited collaboration features. Integration with other tools. It's often difficult to connect these tools with other software, which can slow down workflows. Over to you, Pujani.
Thank you, Mithma. So when evaluating UML tools, it's important to consider several key aspects. So the first one is features and functionality. A good tool support multiple diagram types like use case and class diagrams and offers features such as drag and drop, auto layout, collaboration, and code generation, along with integration with tools like IDEs and databases. Next one is usability and user experience. Tools should have a user-friendly interface, clear tutorials, and be fast and reliable across systems, with trial options and reviews helping to assess their practicality. Next is cost and licensing. It varies with options including subscriptions, one-time purchases, and open source models. It's essential to evaluate licensing terms for user limits, updates, and support. Tools should also provide customization and extensibility, enabling users to modify diagrams, add plugins, and create outputs like code or documentation. Finally, strong support and community are invaluable, with reliable customer service, regular updates, and active user communities, ensuring long-term usability and learning resources. So moving on to the recommendations, AI has transformed the way we create and manage UML diagrams, making the process faster, more accurate, and less manual. Tools like Lucidchart, StarUML, PlantUML, and Visual Paradigm showcase how AI streamlines design workflows. For example, Lucidchart suggests diagram elements and improve layouts, enabling quick creation of complex designs. StarUML and PlantUML take it a step further by generating UML diagrams directly from code, ensuring consistency between between design and implementation. Visual Paradigm leverages AI for predictive modeling and design optimization, enhancing the entire software development lifecycle. So, by incorporating human feedback, allows AI-powered UML tools to learn and adapt based on user interactions. These tools analyze user behavior, such as frequent adjustments or preferences, to offer smarter suggestions and automate repetitive tasks. This makes the tools more adaptive, user-friendly, and efficient, reducing manual effort and ensuring outputs align with user expectations. Ultimately, it improves both the speed and quality of UML diagram creation, enhancing the overall software design process. So now I hand it over to Venuki to conclude the presentation. Thank you.
So in conclusion, AI-powered tools for generating UML diagrams have revolutionized the way we approach system design and documentation. These tools not only save time but also enhance accuracy by automating the creation of complex diagrams from code requirements or even natural language inputs. As AI continues to evolve, we can expect even more advanced capabilities such as real-time updates, intelligent suggestions, and even seamless integration with development workflows. So lastly, AI tools for UML diagram generation are valuable assets in modern software development, combining speeds, precision, and also involving a lot of streamline in the design process. Thank you.